Hello everyone. Today, I'll introduce how to train LoRA for the HunYuan video model using a UI-based approach, making it easier to operate while leveraging free H100 GPUs provided by Modal. All heavy package installations and the training process take place in the cloud. On the local side, we only need to install a few lightweight packages, register accounts on Modal and Hugging Face, have Git installed, have Python 3.10 or higher, and prepare the training dataset. My script not only handles LoRA training but also supports testing LoRA after training. This process follows the sample workflow from Comfy UI HunYuan video wrapper by Kijai with features like TensorBoard visualization and downloading via Hugging Face. I've also added an endpoint for the Comfy UI interface, though this currently only includes 2 custom nodes and a few pre-downloaded models for this workflow. Typically, training a character LoRA takes about 25 to 30 minutes and costs around $5, which is deducted from the free credits. Alright, let's get started. First, we need to download this repository, and I'll leave the link in the comments section. I wrote the code for this project to extend the training pipeline from the Diffusion Pipe repository, adding Modal Cloud integration and creating a UI settings interface for easier interaction. Your system must have Python version 3.10 or later and Git installed. The first step is to clone the repository. After copying the command, you can right-click in the command prompt window or use the shortcut Shift+Insert to paste it. Here is the folder containing the cloned repository. Next, navigate into the folder using cd command and create a new Python environment. This step is optional. You can skip it if you prefer. Then, activate the newly created environment. In the command prompt window, you should see the name of the activated environment. Now install the required packages from requirements.txt. While waiting for the installation to complete, let's sign up for a Modal account. You only need a Gmail account. No additional setup is required. Since I already have an account, Modal will log in automatically. Modal provides $30 of free usage per month, which resets every month. To create a new API token, go to Settings, API Tokens, New Token, then copy the generated token and paste it into the command prompt. Next, we will create a Hugging Face token. This token is used to upload training results to Hugging Face, either privately or publicly, depending on the settings you choose, which I will explain later. Go to Access Tokens on Hugging Face, then click Create New Token. Set the token permission to write, choose any name you like, then click Create. Copy the generated token and paste it into the command prompt, then press Enter to store the token in Modal. The next step is to configure the GPU settings and model selection before deploying the application. At this stage, in the Gradio interface, we only need to focus on selecting the base model for training and choosing the GPU type. For transformer models, you can select either BF16 or FP8. For VA models, you can choose between FP32 or BF16. For GPU settings, you can select either H100 or A100. For training, I recommend using H100. For inference, an A140GB is sufficient. After selecting the settings, click Save Config. Note that if you change the model or GPU, you will need to redeploy the application for the changes to take effect. Press Ctrl+C to temporarily stop the Gradio server and run the deploy command. I'll clear the command prompt and maximize the window for better visibility. Finally, we will run the deploy command. This process will deploy the following components: Comfy API endpoint, Comfy UI, Hugging Face upload and download endpoint, LoRA training endpoint. The script will automatically install the necessary packages and download the required models for training and testing LoRA with Comfy UI. This process will take a few minutes to complete. Once the deployment process is complete, you can see on the Modal website that several endpoints have been deployed with different hardware configurations. Training uses an H100 GPU. LoRA testing via Comfy UI runs on an A100 GPU. File upload and download to Hugging Face do not require a GPU. In the Storage tab, you will find pre-created volumes for storing models and training results. Some volumes are also used for caching. The models needed for LoRA training and testing are downloaded and stored in the HF cache volume, allowing them to be reused in case of a redeployment. This helps save time by only requiring a one-time model download. With the deployment completed, the next step is to prepare the training data and configure the necessary parameters through the interface before proceeding with LoRA training. For the first training attempt, I will train using image data. I have prepared a dataset of 27 images along with corresponding captions for each image, featuring the character Night King from Game of Thrones. Next, I will move this folder into the script directory and rescan the data. Now, I'll adjust some training parameters for better performance. These settings are based on my personal experience after multiple LoRA training attempts with HunYuan video. When training with images, I typically increase micro batch size and gradient accumulation steps to maximize the performance of the H100 GPU. Since the training subject is a character, setting rank to 32 is sufficient. Min frames and max frames should both be set to 1 when using image data. Number of times to repeat the dataset per epoch is set to 10, which is enough for this scenario. In the Advanced Settings tab, I will leave most settings at their default values, except for these two important parameters. Save frequency determines how often LoRA result files are saved per epoch. Checkpoint frequency defines how often training steps are saved. This file is only used for resuming training if needed. There are two saving modes available: save by time interval in minutes, save by epoch. If you change the model or GPU, you must redeploy for the changes to take effect. If you want to learn more about other parameters, you can check the diffusion pipe repository in the HunYuan video example section, where these settings are explained in detail. In the Test Settings tab, you can configure automatic LoRA testing after training is completed. Since I only want to check whether the trained LoRA has learned the character's features, so I will set number of frames to 1. I'll use an existing prompt from the caption file. You can test multiple prompts by entering each prompt on a separate line. Once everything is set up, click Start Training. The script will upload the config files and dataset to Modal. Once the upload is complete, the training process will begin on Modal's cloud servers. At this point, you can safely turn off your local machine as everything runs on the Modal cloud. You can check the progress directly on the Modal dashboard. You can also monitor the training progress through the tensor board, click refresh to fetch the latest log file, wait for the log file to download, then click on this link to open tensor board. In this example, the training process has completed 18 out of 25 epochs and has taken around 20 minutes so far. The loss is still decreasing, indicating stable training progress. In the second chart, the metrics are calculated based on global steps, where one epoch consists of multiple steps. Test result is the tab that contains images or videos generated by the HunYuan API after training, based on the settings we configured earlier. Click refresh to fetch the latest results. Checking the logs on Modal, we can see that the training process has completed and the HunYuan test run returned an OK result. The total training time was around 30 minutes. At the time of recording this video, there was a minor issue with TensorBoard log handling. The program did not download the latest log due to caching and instead used an older log. However, I've already fixed. Switching to the Test Result tab, here are the outputs for the two prompts we configured earlier, tested at the latest epoch. To compare the generated images across different epochs, I will test two prompts with each trained epoch. Switch to the Test Settings tab and click Get Test folder to retrieve the list of available epochs. In the Test Mode section, selecting Latest will test using the most recent epoch. Selecting Specific requires entering a specific epoch number. Latest N will test the N most recent epochs. I will keep all other settings, including the prompt, unchanged. Click Start Test LoRA to begin. After the payload is sent, you can monitor the HunYuan process through the console logs on Modal. During the first run, the process will take additional time to load the models. However, for subsequent prompt tests, the process will be faster since the models are already loaded. You can also check the payload details and results through the CMD console. The results will be saved in the cache folder, or you can view them directly in the UI interface by clicking Get Test Results. The Training Folder section will display the number of files and the dataset name. This is useful when working with multiple training folders, as the dataset name helps identify which dataset the results belong to. Each generated result will also include metadata indicating the epoch it was generated from, which prompt was used, whether it was from a manual test or from an automated test after training. You can also view the results saved in the cache folder. From the results, we can see that the model is gradually learning the characteristics of Night King by the final epoch. Epoch 25. The generated images already look quite similar. However, I want to continue training for 10 more epochs to refine the results further. To resume training, switch to the Training tab and check the Resume option. Click Get Resume Folders to load the latest training session data. Simply change the training epochs value from 25 to 35, meaning we will train for 10 additional epochs while keeping all other settings the same. You can choose to enable testing or leave it unchecked. If enabled, only the final epoch will be tested automatically after training. Finally, click Start Training to begin. Let the training process run on Modal Cloud and we can check the results later. From the logs, we can see that training started from epoch 26 and has now completed, including the HunYuan test run. Click Get Test Results to fetch the latest outputs. Comparing the results across epochs, we can see that by epoch 35, the generated images look quite good. In addition to evaluating LoRa quality through the generated images, we can also check TensorBoard to analyze how loss decreases over the training epochs. However, personally, I prefer to assess LoRa performance based on image quality. Looking at this chart, we can see that loss continues to decrease steadily across epochs. If desired, you can train for more epochs, but I'll end this example here. For character training, I usually train between 25 to 35 epochs, with number of times to repeat dataset per epoch set to 10. Once I determine the best epoch, I will proceed to generate a video using that epoch. After all, we're training a LoRa for a video generation model, right? The image generation step was just a quick way to evaluate LoRa quality. I will test using epoch 35, keeping LoRa strength at 0.85. This time, I'll increase the resolution to 768 by 1024 pixels. Each video will be 10 seconds long, which equals 241 frames. I've used ChatGPT to generate 4 prompts for video creation with this character. Now let's run the tests and see the results. We encountered an out-of-memory error. Right now, I'm using an A140 GB GPU with a fairly high resolution and a large number of frames. After several adjustments and reruns, I need to switch to an A180 GB GPU and redeploy to apply the GPU change. Next, I'll reduce the resolution and decrease the number of frames. Note that I'm using the default workflow from the example of the HunYuan video wrapper node by Kijai without using Tcache. We can also check GPU usage in the overview section. In this section, the Metrics tab will show GPU usage details, while the Files tab allows us to browse the files currently running inside the container. Once Comfy UI finishes generating the results, we move to Test Results and click Get Test Results to retrieve the newly generated outputs. And here are the results of the 4 prompts I previously sent. Next, I'll go over the upload and download features for Hugging Face. In some cases, I think this feature will be useful when resuming training from a different modal account. In that case, we need to upload the results to Hugging Face and then download them to the new modal account. I choose Hugging Face because uploading and downloading from it is much faster than first saving files to a local machine and then re-uploading them. In the Hugging Face tab, click Upload and enter the repository link. If the repo doesn't exist yet, the program will automatically create a new one and set it to private by default. You can also choose whether to upload the test folder. Click Refresh, then select the folder containing the training results. Choose the upload type, latest, specific epoch, specific step, or entire folder. Finally, click Upload. The program will use the Hugging Face token you've set up in Modal to connect and upload the files. To download files uploaded to Hugging Face onto a different Modal account, first, log in to your Hugging Face account via the command line. You can use a previously created token or generate a new one. It doesn't matter. After logging in, restart the UI, switch to the Download tab, paste the repo link, click Refresh, and select the download mode, just like in the upload process. The files will be downloaded to the volume of the Modal instance. In this case, since I'm testing, the folder already exists in my volume, so I enable the Force Redownload option. Finally, here are some test clips using the LoRA model I trained. If you have any feature suggestions, feel free to leave a comment and let me know. When I first started this project, I didn't expect it would take so much time to write the code. Seriously, a lot. I'm not a developer, and I relied on AI assistants to complete the coding for this project. But in the end, it all came together. I'm passionate about AI and hope to grow a YouTube channel focused on AI content. I'd really appreciate your support. So, make sure to subscribe so you don't miss it. If you have any suggestions for future topics, I'd love to hear them. Thanks for watching, and I hope you found this video helpful.